So what is dark matter? To be quite frank, we don't know. No scientist, no astronomer, or guy on YouTube really knows. It's one of the greatest mysteries of our time. We literally don't understand something that is so fundamental to the universe that it makes up 80% of all of its mass. It's pretty crazy to think about. There are some leading ideas, but almost all of them are near impossible to substantiate. Since dark matter is defined as being some type of matter that almost entirely does not interact with the universe, it's pretty hard to observe, at least directly. So how was it discovered then? Well, dark matter was originally discovered when astronomers calculated that galaxies don't have enough mass to stay together. The outer arms of the galaxy spin too fast. They would fly away if the galaxy just had the mass of all the matter within them. This problem, originally dubbed missing mass, is now known as dark matter. But to further the first question, dark matter is just whatever this missing mass in the universe is. So how do we study dark matter then? Well, right now, there are two main ways that we observe dark matter. Through the study of mass within galaxies, and through observations of gravitational lensing. These two methods have been fairly successful. They've even allowed researchers to produce crude maps of dark matter. Scientists are trying to research dark matter using other methods. For example, research facilities like the one at Stanford are attempting to observe dark matter by placing sensitive equipment deep underground. It places equipment underground so that there is no outside interference in their observations. This research hasn't proved fruitful yet, but it is promising. The research is also leading to other second-hand discoveries of unrelated things, which is always valuable when you're a researcher. So, what are the leading theories on what dark matter actually is? Well, there are a ton, so I'll highlight some of the most promising and some of the most interesting, in my opinion. So keep in mind that this is definitely not a comprehensive list. So the first theory I'll talk about is modified gravity. Modified gravity is probably the most anticlimactic answer to the question of the dark matter mystery. It just assumes that our theory of gravity is incomplete and needs additional equations for larger scales. Although this theory is relatively simple compared to others, it would require a fundamental change to the theory of relativity. This is a task easier said than done, and there have been proposed theories like modified Newtonian dynamics, tensor vector scalar gravity, and anthropic gravity. I can't get into the specifics of these theories because, to be quite honest, I really don't understand them to the degree that these mathematicians and physicists do. But essentially, the common theme between them is that gravity at larger scales behaves differently than we assume it does right now. The next theory for what dark matter could be is WIMPs. WIMPs are weakly interacting massive particles. These theoretical particles would have formed early after the Big Bang. They are theorized to only interact with baryonic matter via the gravitational force and the weak force. By the way, baryonic matter is just a fancy way of saying normal matter. These characteristics would make this particle extremely difficult to detect. Currently, scientists are looking for WIMPs using highly sensitive equipment located deep underground. But besides these detectors, researchers are also observing areas in space where they believe this dark matter is, for signs of radiation from decaying particles. One of the interesting things about WIMPs is that they were theorized to exist before the dark matter problem was really known. WIMPs were theorized by physicists who were trying to make a more complete model of quantum physics. WIMPs are also pretty similar to the sterile neutrino, another theory for what dark matter could really be. A neutrino is an already exceedingly difficult particle to detect, but we have actually confirmed their existence already. Generally, neutrinos only interact with baryonic matter through the weak force and very slightly through the gravitational force. A sterile neutrino would only interact with baryonic matter through the gravitational force. I know I've said this already, but this would make dark matter really difficult to directly detect. The last theory I'll talk about is definitely the most interesting. This theory is the mirror world hypothesis. This theory predicts that there is an entire other universe with its own dark fundamental particles that doesn't interact with our universe through any fundamental forces except gravity. This theory would mean it would be essentially impossible to detect these other particles. When physicists look at the math for this potential theory, there is a potential that dark photons could morph into regular photons, but there is no evidence of this actually occurring. This theory is definitely the most mind-blowing for me. Just imagine an entire another universe that occupies the same space as ours that we can't interact with. Dark matter, whatever it is a large part of the universe that we simply do not have an understanding of. To me, it's a reminder of how little we really know about the world around us. As far as our sciences have come, there are still great mysteries out there that we don't even have a handle on.